Did you know that approximately 95% of the cosmos is yet unknown, and new forces and exotic particles are still waiting to be discovered? We have amassed a vast corpus of knowledge about the universe around us throughout human history. Strong telescopes allow us to observe both the beginnings of new galaxies and very old galaxies. The facts we have gathered in particle physics and astronomy tell us that we still only know about a very small portion of the cosmos, although we are aware of how the universe came into being. When we look up at the sky, we can see that matter is organized into gigantic galaxies. Planets, stars, and gases are found in galaxies. The neutrons, protons, and electrons that make up atoms make up the entirety of the visible universe, including the Sun, Earth, stars, galaxies, and everything else that constitutes us. Let's look into the unknowns of the universe we know little to nothing about. Dark matter. The realization that less than 5% of the universe's mass is made up of ordinary matter was perhaps one of the most unexpected findings of the 20th century. An invisible, mysterious element known as dark matter, which constitutes up to 25% of the universe, and a force that defies gravity known as dark energy appear to make up the rest of the cosmos, roughly 70%. Dark matter is an exotic, unidentified substance that appears to not absorb, emit or reflect light, making it invisible. Dark matter is assumed to exist based on the gravitational impact it has on galaxies. We can see the traces of dark matter only at vast galactic or supergalactic scales. Astronomers' observations of optical illusions deep in the universe may also be explained by the presence of dark matter. For instance, some images have shown arcs of light and strange rings. Black holes. Black holes are mysterious objects that have long piqued the curiosity of both physicists and astronomers. They are frequently portrayed as very dense extraterrestrial objects whose gravitational pull is so strong that not even light can evade them. What else do we understand about black holes, though? While the origin of stellar black holes is generally known, this is not true of supermassive black holes. Although we don't know much about their beginnings, we do know that most galaxies, including our own Milky Way, have them at their centers. You might be surprised to know that they can actually be millions of times bigger than stellar black holes. The Big Rip. According to this idea, the universe will end with a big rip as the universe's gravitational pull becomes stronger than its own. Black holes, galaxies, stars, and even our Earth would all be destroyed as a result of this. As the universe's expansion accelerates, Earth and humanity could slowly deteriorate into radiation, collapse in on themselves, or be torn apart. The result would be a universe full of isolated, single particles. Big Crunch. The Big Crunch is yet another theory presenting to us the possible end of the universe. If the matter in the universe eventually reaches a point where it starts to contract over time, rather than expanding indefinitely, gravity might then take over as the dominant force. This would eventually lead the universe to contract, resulting in the collision of planets, stars, and entire galaxies, effectively causing the universe to collapse in on itself. Big Freeze. According to the Big Freeze theory, the universe would theoretically expand to the point that there would be insufficient gas to support the formation of new stars. According to that theory, the universe will almost entirely run out of energy, turning time into an unending emptiness in which nothing ever occurs. We do not yet know whether our universe will end in a big freeze, big crunch, or big snap. But we can all agree that our universe is full of unknowns that we know nothing about. I hope to see you in the next one. Till then, keep rocking, and be sure to subscribe to us for new videos.